Hi guys, I'm Sai Krishna. So let us look at the question number 1. In question number 1, we are given the value of g of x as uh, some values between some ranges, and we need to calculate density function and distribution functions of y in terms of density function and distribution functions of x. So let us look at the solution for this problem. So here I've drawn the graph for the g of x. Okay, given that x is less than 0, the g of x value is 2. So I've drawn the value for the value 0, for the value of x less than 0, the g of x value is 2, and between 0 and 1 it is 0 again. Okay, and then between 1 and 2 it's minus x plus 1, so the line goes below, the slope is negative, and then minus 1 for x greater than 2. So in this way I've calculated, I have drawn the graph for g of x. So we need to calculate the distribution function of y. So for the distribution function of y, we can clearly see that here for the value of y less than -1, for the value of y less than -1, the value is 0, and 1 for greater than 2 here, because for the value y greater than or equal to 2, the g of x value is a constant graph, so the value uniform graph, so the value of distribution function of y is 1 for y greater than or equal to 2. So I've taken here for the I've basically calculated all the values of all the y values, and then depending upon small y values, say -1, 0, 2, and then again for -1 and 0, and basically calculated the density function of y. Let us look at the how I did that. So for y equal to 1, I have done that by using that. For probability that y is equal to -1 can be written as probability that x is greater than or equal to 2. This can be written as 1 minus distribution function of x when it is true. So and for the value of y equal to 0, it can be written as p of y equal to 0, and that is p of x when it lies between 0 and 1. So it is p of distribution function of x of 1 minus distribution function of x when it is 0. Okay, similarly I've taken the help of this graph and then calculated all these values. Okay, for y equal to 2, the probability that y equal to 2 is probability that x is equal to less than 0. Okay, so x is less than 0, that is f of distribution function when of x when it is 0. So we can from the given data, which is g of x between the values 1 and 2, so here between -1 and 0, we can see that the density function of y can be written as, from the fundamental theorem, it can be written as density function of x by differential of modulus of differential of g of x. So here I've substituted the value of x, which is 1 minus y, and taken the differential, and then applied the modulus again. So it turns out to be a density function of x of 1 minus y. Okay, so in this way I've basically applied the values, like here we have calculated the value of when y equal to 1, we have calculated the distribution function as 1 minus f of x equal x of 2. So I've basically listed all of those here, and then calculated the distribution function again, which is equal to integral of -infinity to y density function of 1 minus alpha d alpha. Okay, because see here we have taken the interval from -1 less than or equal to y less than 0, which is basically this area. Okay, so I've basically substituted it here and then applied the integral. So we have calculated that as 1 minus f of 1 minus y. Okay, so we can clearly see that here for like the other data, it turns out to be 0, the distribution function of y. So it is for y less than -1, it is 0, and then we have calculated this value in the previously, which is 1 minus f of fx of 1 minus y, and then again from 0 less than y less than 2. So it's basically we have changing the 1 minus y as 0 here, because here the -1 is there, so it's 0 here. So and for y greater than or equal to 2, it's 1. So here we can see that for the distribution function of x, we had calculated it as 1 minute. For the distribution function of x, we can see that it's a graph like this, and for the distribution function of y, we have basically followed this up. So it's basically f between the intervals -1, so this is basically -1 and 0. This is a incremental of f of x of fx of 1 minus y. So it increases, then standardizes, and then after it reaches 0 till 2, here it is 2, it is a constant graph of 1 minus fx of 0. So this is 1 of fx of 0, this one. And then I've basically put in the other, this indicates the these values, the fy of y, okay, these two values, this and this. So yeah, so we are given with the data here as fx of x, so I've just copied it down. And then for density function of y, we have taken the we have just followed up with this graph, which is fx of 1 minus fx of 2 impulse function of y plus 1. So it's at -1, it is there is an impulse function, and its area is 1 minus fx of 2, and also at between -1 and 0, it's there's a function fx of 1 minus y. So I've written it down, and then here we can see that at y equal to 0, it's fx of 1 minus fx of 0. So it's so at 0, it's fx of 1 minus fx of 0, and then at 2, it's fx of 0 minus impulse of y minus 2. So at 2, there's an fx of 0 area, and then that's it. This is how I've calculated and solved the answer. Thank you.